Well, this is the next engine that I've taken off the to-do shelf, and it is, as you can see, in quite a sorry state. But it's not really surprising because this is a rather old engine. Now, at first glance, it looks like an American Empire Model Steam Engine, and it's made by the same company. It's made by the Metalware Corporation, which made all the Empire engines. But this engine is not badged Empire. We'll let it come round and we'll have a look at the nameplate. This engine is in fact badged Empco, and it's model B-43. Now, the Metalware Corporation mainly sold their engines under the Empire name, but they also sold them under various other different names. One of them was Empco. And this tells us quite a bit about this particular B-43. The B-43s, whatever they were branded, were first made in 1930. But not long after they were first made, they changed the design. So in the 1930s, the design was changed. Originally, they were a double-acting oscillating cylinder, which is what this one is, which makes it a real early one. This will probably be somewhere like 1930 to 1935 manufacture. After that, they were all fixed cylinders with valves. And I've got a couple of other Empire B-43s which have that valve arrangement. So this one is very old. You know, where are we? 2022. So, yeah, in a few years' time, it'll be 100 years old. So, yeah, it's an old engine. Now, despite the fact that it's in a bit of a sorry state, as you can see, it's very, very rusty, and it's even worse underneath the base plate. It's pretty much complete. It's missing the regulator valve, but that's only a threaded rod with a wooden handle on it, which screws into here. It's missing that, and it's missing the whistle top. But then these types of engines, the Empires, they're nearly always missing the whistle top. It just goes on there because they just pull off, so they get lost over time. But other than that, it is complete, and it's all free and everything. There is a little bit of damage, which I'll stop it when it comes around to the front of the boiler, so you can have a look. There we go. Someone's pushed in down on the smokestack safety valve, and they put a dent in the top there, and there's a little tiny dent in the end of the boiler. These boilers are incredibly well made. It's very, very thick metal the boilers are made from, so these dents pretty much irrelevant, and I'm not even going to attempt to take it apart and get those out. It's fine. It's not going to cause a problem. So yeah, so there's going to be quite a lot of work to, I think, to the base and the firebox, but I think that the nickel plated boiler that will clean up with a gentle bit of metal polish and some microfiber cloth. That will clean up, as will the cylinder and the engine block, and you know, it's just really the base and the firebox that's going to need all the attention. So yeah, let's get on with it. The first thing I'm going to do is check the heating element before I do anything else. Now, it occurred to me that I've said this in many videos I've done on restoring model steam engines that have electrically heated boilers, but I've never actually explained how I test the heating element. So I thought, well, we'll get into that just a little bit so that you can see what I do. Now, again, I'm sure there are many ways to do this. This is the way I do it. I'm not saying it's the best way, but it suits me and it works. So this is how I go about testing these heating elements. So we're going to have to do a little bit of basic maths here. So for at least half of the 4 people that are actually watching this video, I'm sure you've already tuned out by now, but it's fairly straightforward, so stick with me. Now, if you remember when we looked at the nameplate on the Empco engine, there was some information on there. It told us that the heating element was 115 volts and it was 300 watts. So from that, we can work out the current that the heating element draws. Very simple. This is the formula for power. It's volts times amps equals watts. So it's 115. We don't know the amps. That's what we want to work out. And it equals 300. So that way, the current will be, take the 115 down there, it will simply be 300 over 115, which means that our heater draws 2.6 amps. Great. But what we need is the resistance of the element. So for that we used good old Ohm's law, which is V over, well, it's normally V over I, it's normally written as V over I times R, but we'll be using A instead of I because it's amps that we want to measure. So juxtaposition this formula to get resistance, which is that, which will equal volts over amps. So we know that the volts are 115. We know that our amps from that calculation are 2.6. That will equal 44 ohms. So we know now that if that heating element is okay, it's going to be round about 44 ohms. Right, over to the multimeter. So, sticking our multimeter on ohms, there we go. And we stick our probes onto the two pins that are, they won't actually clip on, I'll have to hold them on. And they're quite corroded, so I'm going to have to fiddle around with this. 37.9 ohms, 38 ohms, we'll call that 38 ohms. I don't know whether you could see that clearly, but I'll do it again, and this time I'll close in on the meter. There we go. Right, I'll stick these on here again. Yeah. 38-ish ohms. So okay, it's not 44, but it's close enough. Yeah, we can also work backwards through our formulas. We know that the measured resistance of the heating element is 38 ohms. If we put that back into our formulas, that will give us about 3 amps at 115 volts, which will give us about, I don't know, 345 watts. So that's absolutely fine. These heating elements, over the course of the life of the Empire engines and the Empco branded ones, these heating elements varied between 300 and 400 watts anyway. So you know that's I know it sounds like a large variation, but that's well within tolerance. So 38 ohms, that's not bad at all. The other thing I will check is to make sure that neither of those two pins, whether you plug the power in, is going down to the boiler or the chassis or the firebox or any of the rest of it. So to make sure that the element is still isolated. But we're going to have it all stripped out anyway. So that's the first test, and that's a good one. We're good to go with the heating element. Next stage, taking it all apart.